Alright, so for the remainder of the class, what I'm going to cover is concepts around how do I add a class to my project, how do I utilize some of the basic classes within the framework as it pertains to collections, how do I interact with some of the other base classes such as strings, date times, numbers, how do I convert between those types, and just kind of that basic kicking things around type of concept again. So to start off, I'm going to go ahead and create a new class file. I'm going to actually comment out all of this. And one thing that you may like, I personally do, is the fact that you can go in and collapse a lot of your content. So you have little plus signs on the left-hand side. So if you're working on a chunk of code, you're working within a particular function, you don't like the clutter of everything else around, you can collapse those down to just definitions. Comments also collapse, so you can just get really concise, small chunks of code if you're wanting to look at particular pieces. To add a class to your project, all you do is right-click on the project that you want to add the class to, do Add Class. That'll bring you up with a template box. Class is the one we want. There's other options. We'll get into those later in the class. And then you just go down here to the name. By default, it gives you class 1. You give it the name you want. So we'll call this program 2. So it'll add a second file to the project. Give it the same name in code as the file name, so program 2. And then from here, I'll just create a new static void main. I forget the second half of the structure. String array args. Okay. So what I've essentially done here is I've replaced program.cs with program2.cs. So now when this app runs, it runs out of this class file. Okay. So let's start off with what's a scenario? What's something that we need to do or should be able to do? To kind of complement this, I don't know if I said this before, but I work in a school district. So for me, I always like to use models of things in a school district. So what I'll probably start off with is we'll add another class to this project, and we'll call it a student. Okay? The student class will have a series of properties and methods, and I'm going to just give it some basic properties and talk about what properties are in C# as to what they are quasi-treated as in Java. So a property, so let me maybe take it the other way. So inside of Java, you can create classes. You can create properties, particularly within beans. Usually those properties look like, so if this is a first name property, it says string get first name void set first name string first name or value. Right? So if you wanted to create a property, you would declare it in some fashion like this. Because you don't actually have a structure type that is a true property. In C#, you actually have a declaration type where you can declare a property. So if you do that, the first thing that you'll want to do is you'll want to create a local variable, first name. I personally like to put underscores in front of them. That way, visually, I can see this as a private local variable. We can describe it with private so that it's not accessible outside the scope of this class. We can then make these public. So again, this is how Java does it. And then get first name would look something like this. where set first name would be first name equals value. Right? Okay. In C#, we would almost treat it like a variable declaration, how we started. So we'll say public string, and then the convention that's used in C# is that any property or method function is capitalized, where in Java you always start it with a lowercase letter. So this will be our first name property, and then we'll add open and close curly brackets. Now, instead of actually having function declarations, we have get and set segments to our property. So we start off with get and set. Okay, you see the parallels there? Get is the return, and set is like that. Inside of the context of this set, the keyword value is always the value coming in.
So it's like the input
Of the parameter, yes, the input parameter in the Java scenario. So it's always value. So if I create another property, if I can type, it's always value. Now in this particular case, I haven't declared last name yet. I do get a little accelerator pop-up here that I can click on, and Visual Studios will say, hey, you've declared that you've utilized this variable name, but you haven't actually declared it. What do you want to do? I can create a property called _last name, which I'm working on building a property, so obviously that's not what I want to do. Or I can generate a field stub, which is a private variable, they call them fields, inside of week2app.student, which is the class I'm in. I'm going to choose the latter. It went ahead and jumped up here and created private string last name for me. It inferred the data type from the property, from the context, and then took that name and generated a variable for me. Do you like Visual Studios a little bit more?
No,
You don't like
I don't know.
the wizardry, the voodoo?
Yeah, there's too much voodoo in it. Just gonna get pen and paper, gonna write it out better.
So, well, I'll give you some more voodoo. It's actually the language. So until version 4, yeah, you always had to declare properties like this. Pain in the butt. Finally, they got to the point, Microsoft, in the evolution of the language, said everybody always has to create private variables, and all they do are these basic gets and sets, and it's a lot of tedious work if you're not doing any sort of logic or validation. So, logic and validation, what does that look like, first of all? So let's say inside of this set, we wanted to make sure that when we're setting the first name property, that we're actually getting a value in. Inside of here, we can treat this like a method and say if value dot length, the length of the string value that's coming in, is less than or equal to 0, we could throw an exception, name required, else do that. Okay? So inside of this set, I'm actually treating it somewhat more like a function because that's how it's handled. It's a function block handling the set. So when I, as the programmer, let me jump back to program 2 real quick. So I'll create an instance of a student. stu1.property, there's my first name property. Notice you don't see underscore first name in the list because it's private. But the property itself, first name is public, equals, and then if I put in a null string here, when this line executes, it's going to take this null string, set value equal to that string, get the length of it, determine that it's less than or equal to 0, and throw this exception. If it's greater than 0, else, then it takes the value and sets the private field variable equal to first name equal to that string. So does that chain of command make some sense, how that flow works? Alright, so normally programmers don't do that. If you have certain business operation situations in your application where you need to validate values before they come in, you would do that, but normally you're just worrying about that public and private side of your property. The shorthand is public string address, so creating another property called address, my curly brackets, and then inside of here all I have to do is get set. So these two keywords tell the compiler, go create a private variable at compile time, insert it into this property, doing the wire up, seen above. Okay? So this one line of code, the compiler will go in and create private string address at compile time, and then we'll generate basically this kind of a block for you. So you don't have to declare all these private variables and do all that work in order to generate a property. You just put in the name of your property, just like you would a variable, and then say, get me a get or a set, or get and set. Now, there exists properties where they're get only, where get is public only. So that means that from within the class, you can set a property. So we talked about before that idea of building a class that does mathematical calculations for you. So let's go ahead and add another class here real quick just for demonstration. Alright, so I have a class here called doMath. It will have okay, value 1, value 2, and an operator. Then we'll also have a float, which is the return value. And we want to be able to get the value out of this property, but we don't want what we can think of as the user, the person using this class, to be able to set the return value. They have to go through and use the methods of this class to get a return value. So we can say private set. This is the equivalent of saying okay. So then what happens is that we have public void add, or actually let's just make it even more generic. Calculate. We'd have a switch in here that looks at the operator. Have probably some case statements. And then inside of here we would say return value equals value 1 plus value 2. Right? So as the outside program, I can say here value 1 equals value or equals 2 equals 2 equals plus calculate so that's how we'd get that return value out. If we attempted to do math obj.return value equals 5, the compiler will give us an error stating that return value, well, let me fix the other issue. There it is. It says the property or indexer do math.return value, oops, sorry, cannot be assigned to. It is read only because that set doesn't exist. You can't set the property. You can only get from the property. So if we comment this out and turn this on, we get the same result on the outside. On the inside, we still have access to return value because the set is private. So we reference it from its method name, or I'm sorry, its property name. We don't reference a private field variable. But being able to set that property can only be done inside the class. We'll still get that same exception. Now this one's a little more clear, but it says cannot be used in this context because the set accessor isn't accessible. So, same thing. Alright, so it's my side tangent. So we have different ways of declaring properties, but we don't do it this way anymore. Okay.
If we did it that way, does it still work?
It still works, but what you'll see then is out here is when you call stu1 dot, you have first name, but then you end up with a get first name and a set first name method.
Okay.
So they're shown as methods because that's what they are. They're not properties. So your methods always are denoted with a little pink triangle. Properties are the little piece of paper with a hand holding it. So, and again, you can collapse these down to make the code look pretty. So I'm going to add a couple more properties here. There is also some shorthand or shortcut text that you can type in Visual Studio. They call them snippets. So if you're wanting to declare a property, you can type in prop, and you'll get one of these little icons that looks like a torn piece of paper. If you hit tab twice, it will bring up a template for you so that you don't actually have to type out that whole property line. And then I can just simply go in here and say string, tab, and it'll bring me over to the next property, or the next field in this property declaration. And I can say state, hit enter, it brings me to the end of line, prop, string, zip code, enter, prop, string, phone number, enter, prop, email address, enter. So, if you can save yourself some keystrokes, it's always a good thing. Email address is a class. It does exist. I don't have a using statement above for it, and I don't have the correct includes apparently either. So let me jump over to my references, add a reference from .NET. I'm going to include the system.net DLL. Which apparently still doesn't include this. Okay. System.net.mail.email address. Oh, I'm sorry. It's just address. No mail address. There we go.
I don't remember if it was VB or NetBeans, but you could like so the variable or like a set of variables and like go through this like refactor or something on these menus and it would set up like the whole get set thing for you. What was NetBeans?
NetBeans? Oh, okay.
NetBeans generates schedule servers for you.
Oh, okay. So it'll actually go in and do that for you? Oh, okay. So you declare your privates and then it goes and builds your getters and setters. Mm-hmm. Oh, that's pretty good. That's pretty good, actually. There is a little trick. You might like this. It's kind of along the same lines. Let me think of a property. Okay. So, you're in here. I have a student instance created. And I decide I need a homeroom. It's going to give me a little error saying that it doesn't exist. If I can get it to come up. Okay. So, it doesn't exist. I can click on the accelerator. I can say generate property stub. It'll go ahead by clicking that. It'll create that property for me, pre-configure the code, and infer the data type from the initializer. So, not quite as cool as what it does in NetBeans, but if you're in the middle of a chunk of code and you're like, oh, I need that property, you can just type it, click it, and it'll at least pre-build something for you so that you can move on. So, that's always a nice little piece. All right. One thing that is probably more noticeable if I jump back here for a moment. So if I do console.writeLine, let's go back to that method again. When I come over this method, I get this nice little block of explanation around what it is. It gives me a summary of what the function does. I can even go inside of here to the different overloads, and it'll tell me what is expected for value. Char, buffer, Unicode character array. So it gives you these descriptions around these values. You can actually build your own. And by you can build your own, I mean I'm expecting you to put these in. You can go in and actually put in summaries and descriptions. Do you? Yeah. Okay, yep, exactly. Same exact concept. So Visual Studios will help you through building those. If you just do 3 forward slashes, like you're doing a comment, it'll build what they call XML notation. By default, you get a summary block for any properties or classes, and it's simply, this is the first name of the student. This is the last name of the student. Okay. Coming back to again, that user side of it, the code side that's using this class, I can come in now and I can mouse over first name and it'll give me that description. Method, you get one better. Whoops. So if we have public, what's a method? I don't know. I'll just come up with something. Do work. String classroom. Okay. 3 slashes again. I now get a summary block. And then the parameters actually get their own description as well. Okay. Whatever that means. Flip back out to the other side. Go do 1. Do work. It'll give us that description. You go in to start to actually complete the method call, and it'll tell you that classroom is, this is the room, the room number the student does work within. So you can help document, notate your code for yourself and for anybody else. So if you're working in a partnership or a team or something like that, this is always handy when you're building a class for someone, you're giving it to them, maybe with code, maybe without code, so that they at least have some point of reference to this is what this is for, and this is what this method does or doesn't do, and these are what these values are expected to be. So I, as the person not writing your code, expect these so that I can understand what your code is doing, even when sometimes maybe you don't understand what your code is doing. So getting those in there is definitely helpful for me as I'm debugging and going through and grading. All right. So within this application, what I'll probably do is create a student. And to do that, I'm going to ask for information from the console. Read in the information and create a student object. So we'll say student, stu equals new student. Start off with a console.writeLine. Read the name from the console. Okay. Yep.
This is kind of off topic, but I just thought about it. In Java, in order to know where something was in a string, we have like string delimiters. Like it would lead up to the colon, and then it would break the string in half, fold it into 2.
Yep. Where you could delimit this. Okay. Yeah, I know what you're talking about.
Is that what we do for like a calculator then? Like look for like a operator sign?
You can. I mean, so you have a lot of options about doing it, but that is one approach.
Okay. That's
Yeah. So yeah, there is, and that's part of what I'm going to kind of go through here right now is talk about some of the functions and routines within a string. So the end goal here is to be able to read some values from the console and then populate our student object. What I'm going to also do here is do dot So what we need to do here is parse first name, full name into first and last. Validate age as a number. Validate birth date as a date time. So what's coming off the console in every case is going to be a string. Whether you're reading the full name, obviously will be a string. The age, read line returns a string, so you're going to get a string back as an age. Birth date is also going to come in as a string. So to handle those, you're going to have to treat them in different ways. The full name, which obviously is the easiest. So you just talked about using that delimiter they call it split in C#. It's a method off of the string class or the string type. So what we actually need here is we'll need a string array, which is the full name parts, and then full name, and then split, and then we can provide the character to split on. So it's a char. So to provide a char or a single character, you use the single quotes to designate it. You can only put one character inside of those single quotes, otherwise the compiler will get very mad. If you do it with double quotes, even though it's one character, it's considered a string. Double quote string, single quote char. Okay? So I did a single quote with a space. And what that will do is it'll take full name, split it on the space, and then we'd probably do something to the effect of full name parts dot length, checking the length of the array, is greater than 1. Then we do full name 0 equals full name parts 1. Okay, simple enough. Bringing an integer in from the command line, or what we believe is a number, the simple way is you can say int.parse age. So parse takes in a string and returns back an integer. So then we'll say stu.age equals that. stu.date, birth date equals, and you can do date time dot parse, and then we can just say birth date, same concept. So if we run this, let me actually do this as well. I'm going to put a breakpoint here, which will cause the code to, as it's executing, it'll basically stop at this point and jump back inside of Visual Studio. Or it's supposed to. So at this point, we've declared our student, asked our questions, taken that full name, and done the split, which gives us a string array with 2 parts. We can expand that and look at what those parts are. So Kevin and Gantos. We can look at our student object that's been instantiated. We can expand that and look at every property inside of that object as well through the debugger. So there's Kevin, there's Gantos. In those private field variables, here's our properties. There's our age and our property. We don't see the field variables because they don't exist to us. They exist to the compiler. So it just gives us the name of the property and the value. And birth date hasn't been set yet. It's the 4/20/2012. It's just not set inside of this property yet because this line hasn't executed. So if we click down one more, we'll jump to the end of the executing line. Birth date is now 4/20/2012. Everything is good. And then the app exits. So we can do one more thing here. We can say console.writeLine. So then there's our output coming back out of our class onto the console. Then I'd end up with nothing. Well, it won't. It will skip initializing the property. Yes. So it won't do anything. So in that case, we'd have to change up our logic a little bit and say if it's greater or equal to 1, do that. If full name parts dot length is equal to 2, then do that. So then that'll give us the effect that we're looking for. Yes. Well, it's actually how the parser handles it. So, watch this. So if I put in Kevin, no big deal. Gantos. So now what's going to happen? Correct. All right. Actually, it drops the Gantos as well. Right. So I said it's equal to 2, so obviously it's greater than 2, so I lost it. Another situation that we haven't really considered. So what if I'm just messing with it and I make a typo, my hand's in the wrong spot, and instead of hitting 10, I put... Right? No big deal so far. 4, I did this already, 2012, I hit enter. And I'm going to get a format exception. So what the exception is saying is that the input string is not in the correct format. I'm going to close that and get it out of the way. Age is QP. QP cannot be parsed as a string. Therefore, there's an exception. And I don't think it'll even break past that exception. Nope, so now we're stuck. So basically, if our application was running without a debugger, it would explode and we'd be done. It'd be over. So what's the solution to that? You have a few options. Faithful try catch block. Okay, I know most of you guys use these, so you're pretty familiar with them. So if EX... Or I'm sorry. So then we can say console.writeLine invalid birth date or invalid age ex.message. And then on top of that, we have to go into this whole round robin thing of while stu.age is, I don't know. Do all kinds of stuff. While true, do this, And if that works, then break out of the loop. Right? Now the other piece of that will be console.writeLine. It's basically this line again. We don't have to redeclare age. We just want to store a value in it since we already declared it above. F5. So we'll do Kevin Gantos, QP, 44012. Now we can put 10. And then date time will blow up because 440 is not a real date. Same issue. So the alternative, so this is one way to do it, what we did up here. Okay? Convention says, and actually practice says, from Microsoft and third parties, is that try-catch blocks are necessary, but you should not use them for flow control when there's an alternative way to handle it. So what happens whenever an exception is thrown is a whole lot of stack trace information is generated by the runtime. What line of code did it happen on? What was the code that was executing that got you to this point? Blah, 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 blah. There's a whole bunch of stuff that's created. To get around that, you always want to try to find alternatives that don't generate exceptions. Parse, most base level structures, integers, floats, date times, booleans, all of those, come with them a parse function so that you can take a string and parse it into that other type because it knows that most of your inputs are going to be coming in a string, so you need a way to convert them. There's also a method on almost 99% of them that is its helper. It's called TryParse. So on date time we have TryParse. TryParse takes in a string, they call it S, and then it takes an output parameter of a date time variable. Did you guys deal with those in Java? Okay. Output parameters are the fancy way of saying I already have declared this variable with a return type, but I actually need to return two values. So let's go back and look at the signature again in a little more detail. So you'll notice based on the first line it says bool datetime.tryparse parameters of string s and out datetime result. When you call this function, it will take the string s and attempt to parse it. If it's successful, the function will return true. If it fails, it will return false. So you can wrap it in an if statement. If it returns true, it will also initialize the output parameter result with the datetime equivalent of that string. Okay, so how does this work? To have an output parameter, you have to declare an empty variable, an uninitialized variable, to be set by the function. So we'll create a datetime, and we'll call this dt, datetime, birthday. And we won't set it equal to anything. We're just going to create a variable to house it. And then inside of here, let me get rid of that, we'll say if datetime.tryparse, so if it returns true, parse birth date and give me back an output parameter of dt birth date. So logically what this is doing is it's saying try to parse birth date. If you can parse it successfully, set dt birth date equal to that value and then return true. If it returns true, then we can go on and say set the student's birth date equal to that dt birth date value. Else, And then we go back up here and we steal our prompt again. And then we can do the same work we did before, where we can say while true, and then throw a break in here. Okay? So let me zoom out a little bit so you can kind of look at them both. So they're almost identical. The primary difference is that you've not thrown and caught an exception, you've done it through another means. You want to see another example of that output? You want me to redo the int so you can see it? Yeah. Okay. So, first thing we need to do is have, well, first thing, we don't need the try-catch block here. We'll turn that into an else. We now can say if int.tryParse, we'll pass in the age string, and then we'll have an output value of iAge. That'll be our integer that we're going to get back. And we'll do something to the effect of iAge. Oops. iAge. So I'll declare an integer called iAge, and this will be my output parameter variable. So iAge will be my catcher. I say, and maybe it might be a little clearer for you as well, so I'll say bool can parse equals this. So if it can parse, so try to parse age, return true or false, whether or not it can parse. If it can parse true, iAge gets set to the integer equivalent of that string. Can parse true, set the age, break out of the loop. Else, invalid, give it an error, say how old is the student, and wait for a response. Try it again. Okay?
So I is kind of like, it's like two active values. Like if age is an integer, right? Because it checks iAge to see what type iAge is first.
No, what it's actually doing is the TryParse is part of the integer, the int data type. So TryParse is actually a static. It's one of those static functions we talked about last time, how you have these utility classes with static functions. I think a few of you, or I saw one at least, that used a static function. So basically, this is a class or a structure. It has a static function called TryParse that's unique just to integers. The datetime one is unique just to datetimes. So now if we run, after I fix my build errors, oh yeah, it doesn't exist. I can't say that. Okay. So now I'll say Kevin Gantos, QP, to invalid age, 10. There we go. And we run it one more time.
What if we get it wrong on the second try?
Oh.
And it's just an error again?
Yeah, you just get the error again. Did you notice that it picked up the typo in the birthday? What it did to it? I did 4. What did I type? 112. I think I did it like that. So it took it as a year. So it parsed it as month/year and ignored the date. So you gotta be kind of careful with some of those. They get really interesting because they try to assume what you're thinking based on what you type. So, yeah. So the issue that we're running into with the first name, we've got a few options of how we want to deal with this. Obviously, we could just come in here and say if it's greater than or equal to 2, that'll take care of it. But really what we want to do is capture everything after. So option 1 is we can do a for int I equals 1, comma I is less than full name parts dot length I plus plus. Basically say I plus space. So what this will do is it'll just loop through all the remaining items and start concatenating them onto the last name field. Ideally, it should give us didn't even give us that. Why did it do that?
Because the first statement is greater than or equal to 1. Never mind.
1.
Does it start at 1? 0?
Well, it should start at 1 because 0 is the first name. Oh, I know why. Stop debugging. Plus equals. So we put Gantos in, then it will loop, and then we put the 3 over top of the Gantos, so we never got the the rest of them. Here. So that's one option. Option 2. Which actually would kind of replace the whole functionality of this. But what we could do is say full name dot index of space and then we could say stu dot last name equals full name dot substring, which will grab a subsection of the string. The starting index is the space index, plus 1.
So it looks for the space puts everything after it.
Mm-hmm. So you have it locate the space inside the string. It'll return to you the position of that space in the string. So with my first name, Kevin, 5 characters plus 1, 6, but it's actually base 0, so it'll return 5. That's where the space lives, is in the 5th position, base 0. So we want to go to 5 plus 1, which will put us at G, and then give me a substring starting at position 6 to the end, which should then return us the same result. Now, obviously, most common computers today are very fast, so the difference in performance there is pretty marginal. But if you had an extremely long string that you were trying to do a split on, you'd end up doing a lot more computations of walking through that string, splitting it, and then doing the loops after the fact sequentially to build the back of it back together. So the latter is a little bit faster because you're, well, really what we should be doing is before we even get into this parsing piece, we should be saying, find me the first space, and then say stu.firstName equals full name substring, start at 0, beginning of the string, comma, and then we want the space index. We don't need that. basically walk through the string one time, find the space, and then we take before and after and get our result. Equally so, if you wanted to, a string is nothing more than an array of characters. So keep that concept in your head. If we really wanted to, we could do for int I equals 0, comma, I is less than full name.length, I plus plus. You can then walk through the string one character at a time through a loop. It also works with for each. Cool? Give you some ideas for the homework. All right. Okay. Let me just cover one other small thing real quick, just to make sure that you guys are aware of it. I'm going to go ahead and delete, well, yeah, I'm going to delete this. If you want to see it again, it's in the video. Remember that all classes and objects are constructed as a composite of properties and methods. Okay, so all classes, generally speaking, are simply a composite, a collection of properties and methods. So we talked earlier about the idea of a data table class, and that it's there to represent a database table with rows and columns, and each column has a field type and so forth, and each row has data in it. The date-time type is a composite of what? Primarily numbers, integers. Those integers have unique representations. The first number is the month, the second number is the date, the last number is the year. And then if you continue on, you have a number that is the hour, the minutes, the seconds, and then the milliseconds. We saw an example of that with the parser. It tried to parse 4/12 and turned it into 4/1/2012. It tried to interpret those positions and turn it into those values. Quite often you'll use a class and you'll want to actually explore that class or that structure, that object, in more detail. Something I recommend is just creating an instance. So right here we have birth date. Birth date is a date time variable. So if we say stu.birthdate dot, you'll see a series of methods and properties that are a part of this. And they each serve unique functions. So if we wanted to go in and add a day to a date or add an hour to a date, we can go in and actually take that variable as it stands. So if it's 4/20/2012, we can say add days, and then it wants a number of days to add. So it'll go in and add 2 days, 3 days, 10 days to that date structure. So instead of trying to figure out what date do I need to add to it, to what kind of weird equation do I need to come up with to add these days, you can simply say birthdate.addDays. And by calling it, what it will do is we'll say 10. Add days is not a void or a non-returning function. What it will do is it'll leave stu.birthdate, that variable, unmodified, but it will make a copy of it, add 10 days to it, and return you the modified version. So in this case, we're going to take 4/20/2012 and add 10 days. So we'll create a new date time, new B day, and new B day will equal 4/30/2012. Okay? Something else that you can kind of just keep an eye on when it comes to these variables or these types is so you have a series of methods, then you also have the pieces of that structure. So this date is the date integer, or date is the date part of this date time. So if this had 4/20/2012, 11:59 p.m., this date property only gives you back 4/20/2012. It strips the time part off. Day gives you an integer. It gives you the actual day. It would give you the 20 out of the 4/20/2012. Day of week is an enumerator. So there's an enumerator called day of week, which has your Monday through Friday and your weekends. So Sunday through Saturday. So the computer basically calculates that for you. You put in a date, it'll actually calculate what the day of the week is for you automatically based on the date on the calendar. Day of year returns an integer again, which is the year. Hour, integer for the hour. Kind, and this is something just to keep in mind if you ever get to the point where you're dealing with dates and times. We live in a spot where we don't really consider it. We actually are living in the Eastern Standard Time Zone. When you start dealing with dates that cross time zones, you have to keep track of that, because if you're pushing a date from one time zone to another, or a time from one time zone to another, you actually have to adjust that time according to the end user's time zone. So when you put something in your calendar and say that I'm having a meeting at 2 o'clock, and you send it to someone in California, it's not 2 o'clock to them, it's 11 a.m. So within the framework, your date time structure actually keeps track of, based on UTC, the Universal Time, I forget the C, that UTC time zone, or basically those time zones. So you can pull out milliseconds, minutes, months, seconds, ticks. I forget what ticks are. I apologize. I totally just drew a blank on ticks. If you want to know what ticks are, you can go research it. I'm sorry. And then year. You also have some additional formatting methods that you can use in here. So if you only want the date part of a date time object and you want to output the date, you can say toShort date string, which will give you just the date part of that date time object. Short time string will give you hours, minutes, and seconds. The long date gives you the fully typed out. Today is Tuesday, January 15th, 2012. Like, it'll actually say the word Tuesday, the word January 15th, 2012. Long times are hours, minutes, seconds, milliseconds generally. So these are just things I just want you to kind of keep in the back of your mind as you're going through and doing stuff. Everything in here has these extension methods, generally speaking. So if you're trying to do something and it's not real apparent, check out the methods and properties. You might be surprised there's something built into the framework already for you to make it easy. So if you get to the point where you're stuck, give these things a shot. It may just be a difference of thinking in how you approach it. Okay, so that's all I've got for the week. The assignment is up on Blackboard. It's due by the end of next class period. It's so you got time the rest of this class to work, and if you want to go, that's cool by me. So have a good week.